And that's it. That's out. See, I like the one. See, both of these books have their pros and cons. That's the one out of the C.D. Stevens, right there. And I really kind of like. I like this one. See, he uses platelet phospholipids in both places, and so I really like this one better. I really kind of like that one a little bit better than this one, but I did show it. He's got too much stuff on the side there. All right, now right here, the intrinsic pathway we already talked about. It's slower and more complex. We already talked about the intrinsic and so forth. And called intrinsic because the formation of prothrombin activation initiated by subsequent in the blood itself. And not that I'm going to ask you that. And then I just go through what I've been talking to you about. Blood comes in contact with damaged vessels, the Hagman factor. And there's factor 12, activates 9. 9 combined with calcium and 7 to activate number 11. Wait. Activate number 9. Excuse me. Number 9 combines with 8 and calcium to activate number 10. And then right here, activated 10 combines with 5 calcium and phospholipids to form the prothrombin activator, and that is it. And that's showing the picture again. That's just a repeat of the diagram. All right, and then this right here. This right here is the common pathway. Basically, y'all, in the common pathway, it's so simple compared to the others. The common pathway is so easy. The common pathway is this. The prothrombin activator or prothrombinase. That plus calcium converts prothrombin to thrombin. Okay? And we're going to go over some anticoagulants and how they work. How an anticoagulant, or as the old folks would say, a blood thinner, how they work. The anticoagulant. Alright, so right here, look. Prothrombin activator plus calcium. And see, if calcium is bound up, blood won't clot. It will not clot. Theoretically, if you had a system with no calcium in the blood, you bleed to death. Blood will not clot. Calcium figures in nearly everywhere. Alright, so right here in the common pathway, I'll tell it to you and I'll show it to you on the screen. Here's where it goes. Prothrombinase plus calcium is necessary to convert prothrombin to thrombin. Thrombin, in the presence of calcium again, converts fibrinogen to fibrin. Then the fibrin is the blood clot. That has to be stable. Number 13 is the fibrin stabilizing factor. It, along with calcium, makes it tighter. Okay, makes it tighter. Okay, so right here, everybody, right here, this is the way it goes. Prothrombin activator plus calcium, prothrombin to thrombin. All right, thrombin, there you go. Fibrin, and once we get thrombin formed, thrombin plus calcium, loose fibrin threads, and then number 13, stabilized fibrin threads. So right here, let's see. All right, common pathway number 2. I don't know why I have number stage 3 down there. That's stage 2, the common pathway. I don't know why I did this. Because right here, I don't know why I put that. You don't need to worry about this. But thrombin. In other words, thrombin and calcium converts fibrinogen to fibrin. Fibrin plus number 13 stabilizes the fibrin. And that's all you need to know. And stabilized fibrin threads. And there's a scanning electron micrograph of early stages of fibrin threads. That's in the blood clot. There's something shows. All right, and then right here, there is a little bit later, a little bit more clotting. There's a real pretty good clot right there. There's a pretty good clot. That doesn't say how much that's magnified, but that is it. There's magnified 1,600 times. There's a red blood cell. There's fibrin threads. Kind of gives you an idea of the fibrin involvement. You can kind of see that a little bit. So we kind of show you, can you see, all right? Can you see? Okay. We can go back up this way, kind of show you some fibrin threads in the blood clot. Now, okay. Now, other topics concerning blood is retraction and fibrinolysis. Now, if you've got a blood clot, it's got to be broken up. What's going to break up the clot? If a kid cuts their finger, cuts their hands, or spins their knee, got some bleeding, got to have a blood clot, and all this has to be broken up. All right, so right here, very briefly. Now, first of all, are there any questions on this stuff? All right, coagulation. Okay.
I just have a quick question.
All right.
On the the two different pathways.
Uh-huh.
On 3 different spots, you have the phospholipids. You only want us to know it for
Yeah, phospholipids.
for the 10 for the.
Yeah, phospholipids are pretty well thought to be between our 12, 11, 9, and 10, and also on the intrinsic mechanism, phospholipids, but I probably won't really be that picky on the phospholipids. 12, 11, between 9 and 10, and between 10 and the prothrombinase on the intrinsic, the phospholipids. That's pretty much both
Because it's
agree
also on
on
the
that.
other one as well.
Oh, I do have it on the other one. Don't worry about that, because it's that's a little bit of disagreement on that one. Don't worry about that. Now, retraction. All right, retraction is the tightening of the clot. Serum will escape. Fibrinolysis is just dissolution. Enzymes released by. Now, here's the thing you need to remember right here. There is a plasma enzyme called plasminogen, and their enzymes are released. Well, plasma protein. Enzymes are released by damaged tissue. They will activate an inactive plasma enzyme called plasminogen into an active form called plasmin. Plasmin will dissolve the fibrin clot after a period of time. All right. Now, there is a stuff that they give in many times for a stroke victim. It's called tissue plasminogen. It's genetically engineered. It's TPA. Any of you ever heard of that before? Nobody? All right, it's called TPA, tissue plasminogen activator. That is given, that's the only thing I know, at least unless it's been changed, it's been approved by the FDA for dissolving of clots in stroke victims. It's TPA, tissue plasminogen activator. Tissue plasminogen activator. In other words, it changes plasminogen to plasmin and will work to break up blood clots. And when you get in the hospital, you'll hear about that. You'll hear about that one. TPA, let me just show you. Plasminogen dissolves the fibrin clot. All right, prevention of clots. Okay, now once again, right here. Fibrinolysis is dissolution. First of all, there will be a tightening of a clot. That happens. That's where you see a little yellow serum, maybe, little yellow stuff. That's tightening of the clot. Then, it's going to go through a period of time. Then it's going to begin dissolving, we hope. Then it will on a child. You run into this mainly with children. Kids outplay, they're always going to fall. Oh yeah. On the fibrin clot, and we talk about that. Prevention of clots, this is kind of important. First of all, a thrombus is a clot. A thrombus is a clot. All right, a thrombus. All right, now an embolus is the moving of a thrombus. Like if I've got a blood clot that formed in the right atrium, a little clot formed there because my atria are not doing this like they should. So I had a little clot. All right, that little clot moved here. That's a clot. That's a thrombus. But it starts moving. It's an embolus.